Hello friends, in this video we will discuss about PLC output cable wiring of Schneider PLC M340. We can see here PLC output wiring diagram, and we have a output cable, and from that cable we have 20 wires which are color coded, and in a relay board we are fixing, you can see here in a relay board 1 plus 1 minus, these are the terminals, one side of terminals of relay board, and we have connected wires. And here we can see a color white, pink, white, gray colors. These are connected to DC positive, and DC negative terminals is connected to pink, brown and gray brown terminals. This has been connected as per the color coding given in the technical brochure. This is the connection diagram of output module, and we can see here we have got uh, these are the terminals where we have PS. These are the PPS2 plus and PPS2 minus terminals, and plus terminals are connected to the DC positive terminals, and PS2 minus is has to be connected to DC common. So we have two connectors A and B. These are the 32 point, and other one is also 32, and this is basically the display part of output module 0 to 31. This is the indication of digital output from 0 to 31. Now this is a relay board, and as we have shown in the diagram, uh, this is 1 plus 1 minus 2 plus 2 minus, and as per the color coding from 1 to various sequence we have connected all the positive terminals. All the positive terminals of relay board are connected to DC output, and below it we have indication of that particular relay, and also we have shorting links. See here we have, these are the shorting links of relay, and these are various shorting links, and these are connected at negative sides. So each relay negative point is shorted basically. Same way in this relay board also, these are the 8 wires, other 8 wires all are sequentially connected at the positive sides of the terminal, and negative terminals are shorted by a shorting link. And these are the last 4 wires, those has to be connected to DC positive and DC common. As we have shown in our diagram that PS2 plus has terminals are connected to DC positive. So we will connect positive and negative terminals uh, here. This is the black wire DC common. This is the DC common black wire, and this is connected to the last wire. This is PS2 minus wire, and this is the last 20th terminal, and we will connect a common terminal to this 18th terminal also. So 18th and 20th, these are the two terminals, and this has to be connected to DC common, and that was indicated as PS2 minus terminals. You can cross check with this technical literature also as per the color coding. And this is a 19th terminal which we are connecting to DC positive. Red wire is a DC positive wire, and we are connecting it to 19th terminal and 17th terminal. This is the 17th terminal. So this is a PS2 plus terminals. So these wires as shown in the diagram, these has to be connected to DC positive and DC common. So we have connected DC positive and DC common to the required wires, and this is basically a fuse terminal. So it has to be connected using a fuse terminals, so that if there is any problem, the fuse will blow out and the circuit will be safe. So as per the color coding, we have arranged from 1 to 16 wires, and last four, that is 17, 18, 19, 20, these are arranged at this fuse terminals. And now coming back to the relay board, we can see here all the positive terminals has been connected to the PLC output, and the minus terminals are shorted, but we have to connect minus to a DC common. So now we are connecting a black wire, which is a DC common wire, and we will connect DC common to this black minus terminal. And also in this relay board also, this wire will be shorted here. This has to be connected to DC common. So all the shorting links and this wire has been shorted, so all has been given a DC common supply. Now this black wire will be connected to the supply somewhere where we are getting DC common, and here at this point we are getting DC common. So we are taking DC from this point. Yeah, now it is completed. See here, finally we have completed our input side of relay board wiring. All the outputs are now ready. And now we have to switch on this PLC. Let's see what happens. We will power on the PLC, and see here it has been switched on, and the rightmost module is basically a 32 point digital output module, which is DDO3202K. Right side module is a digital output module 32 point, and before it is a DDI, which is a 64 digital input module. We will concentrate at the digital output module, and now here you can see 16 is indicated. This means that 16th output is switched on by a PLC. 16th output. So we have connected this wires, and these wires are basically from 16th to 31. These are basically the wires output from 16 to 31, and the first output is indicated, and the relay is switched on here. This was basically due to the default program already in the PLC, that's why it is switched on. Now we will make an make a basic program and switch on a particular output. So this is basically a ladder logic software where we will make program. And first we will create a memory bit, and we are trying to build a simple program to switch on a particular output. This is basically NO element and normally open contact element, and we will create this as a memory element, memory bit basically, and let us name it as test bit. So this test bit is basically a memory bit, and the PLC will ask what type of variable this is, and this is type bool, means digital type of variable it is. This is 0 or 1 memory bit, test bit. Now we will take one output. This is the output coil, in a ladder logic, and we will place at the right side of this screen. So we have placed digital output at the right side, and now we will address it particular real output. We have to address it, so it has to be addressed in a percentage q style. So it will be, let's say, percentage q0 dot 2 dot 18. So this is the basically, this means this is the 18th output of second module, 18th digital output of a second module placed in a rack, placed in a zeroth rack. And as here, see here the configuration, hardware configuration. In the program we have processor, we have a rack BMX XBP 4 slot rack, and last one is a digital output module DDO. Yeah, this one is a digital output module, and we will click here and we will check here how we can get the PLC output address, which was written as percentage q, this type, how we can get it. So we have selected here output module, and we have opened this screen, and we will select here DDO module, and here we will go to IO objects tab. Yeah, this one, IO objects tab, and here we can see here it is a percentage q. We will check it, percentage q box, and we will click the upgrade grid button, upgrade grid, update grid. So after clicking it, we will get the addressing of percentage q of this particular output module, percentage q 02.0. In this way we will get all the addresses of this particular module. These are e-bool. E-bool means actually the real output of a module, and bool means a memory bit, digital on off. E-bool is a real one. So we have 32 point module, and the last address will be percentage q0 dot 2 dot 31. 2.31 will be our last output module, because our outputs are starting from 0 address. From this, see here we have the last module is 2.31. So we have in this way, and we have labeled as. Now we will compile the program, rebuild all the project. The system will ask about, we have to say yes, rebuild all project, and now after compiling we will connect, and we will set address first of all, and we have to connect this. We are connecting with a USB port, so it is system and media is USB, and we will test connection. So it is successful, because we have already connected a lead also from here to USB port. Okay, and now we will connect the software to PLC. So we will go to here, connect option. Now the software will ask, and you can see here after connection it is showing different. This ladder logic is different from one already in running in the PLC. So this shows here different. Now we have to download it. This is transfer project to PLC. We have to do this, and this is the PLC run after transfer. We will check it and transfer. We will click the transfer and OK. Now the project is being downloaded to PLC. OK. See here, we have downloaded the project, and now it is not equal. It is showing equal. Previously it was showing different. Now it is showing equal, because the same program is in the PLC and in the this software also, and both are connected online. Now we will toggle this bit, state of memory bit. We will change the state from 0 to 1 by using this set value from set to 1. so it will get one state height, and because it is on, so our output module, this is q2.18, is set to high, it is also on. And now you can see here in our module 18th output is indicated that it is switched on, 18th output. And see here our this 18th relay board is on. We will see. So this way we have checked that our wiring is okay, and now we will toggle it again to 0, and this will switch off. We will set it to 0, set to 0. See here, now this is output is off, and here also 18th output is not available, and the relay is switched off. So we have completed our PLC output wiring, and hope you have enjoyed and learned. Thank you.